I was wondering if like he's already been here or not. I just didn't know him. I didn't want to ask. I was like, who's this new guy?
All right, so tic-tac-toe is closed now. Thank you for all of the too many hours that you spent on that. I really appreciate all your efforts. We definitely screwed up tic-tac-toe a bit, as discussed last week. So if you found it utterly confusing, that's not your fault. It's really closed right now. Like, we published the solutions. Don't work on it anymore. Like, even if you're still confused about it, it's in the past. We're gonna move on. If you have not finished Lab 4 though, Lab 4 is super important and super required, and you have the solutions, so like go catch up on that. Like, leave tic-tac-toe in the dust and go catch up on Lab 4. I also highly recommend Lab 5. We threw it together at the last minute, so I can't really say that you have to do it, but even though it was a last minute thing, I think it was a really good idea, and I'm glad that we put it together. So I think it would be time well spent if you spend your time on it, if you have not already. And if you have already, you're awesome. Class next Monday is the normal class time. It's exam week, so we're gonna do fun stuff, but please show up at the normal time. And next Thursday is the tour, so it's gonna be 4:30 to 7:30. I will send details on Piazza about where to show up, but that is the timing. Cool? Okay, that's all the stuff going on. So this week we are moving on to week 6. There's a new lab out and there's a new assignment out already. So we're covering new material. And today's class is more loops and scope. So what loops do we know already?
For, while.
Yeah, so we know a for each loop and a while loop. And it's called a for each loop, but you write it as for. And then while loop you write as while. And today we are learning a for loop and a do while loop. So that's why we specifically say for each on the other one, because for loop we're actually referring to a different type of for loop. And a do while loop is a variant on the while loop. So let me go into present mode, actually. Hang tight just like 1 second. Stare at this code and try and understand what it does. All right, have you figured out what this code does? I'm seeing a lot of people looking down. Are you looking at the slides down or? Okay. I was like, where is everyone? Okay, so this example problem prints the squares of 0 through 10. So can someone name for me, just like list out the squares from 0 through 10? Big math. Come on, you guys got this. Starts with 0. That's your hint. Alex has got it. You got this. Do like the first 5.
0.
What's 1 squared? Then? You're doing great. Yep. You're awesome. Yep. 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 Nice.
2000.
100. Everybody give Alex a hand. You got the math down. All right, so that's the goal of this code, that it prints out the things that Alex just said. All right, so how does this code do it? Do you guys understand it yet by looking at it? So it starts with, so I is going to represent the thing that we're squaring, right? So it's going to go from 0 to 10. So I starts at 0. Then we print out I times I, so it's 0. Then we do I++, so it goes up to the next one. And then we repeat our while loop until I is 10. So this should be pretty familiar with everyone, right? Cool. Okay. So that's an example of a loop we already learned. So I want you to notice, we've already gone over this as well, that you've kind of got this standard format. You've got the setting up your variable, you've got the checking the thing, and then you modify the variable. So in this case, we started at 0, we compared it to 10, and then we incremented it by 1. So that's kind of like a really common format that we see in while loops. Okay, so here's another example problem. Increment every element in an array. So for example, if we start with the array 9, 8, 7, we would want to end with the array 10, 9, 8. Does that make sense? What it's doing? So if we started with the array 1, 2, 3, 4, we would want to start with 2, 3, 4, 5, or end with 2, 3, 4, 5. You're making a face like, what the heck?
Yeah, I missed the first part.
Okay, so so our problem here, what we're trying to do is we're going to increment, meaning increase by 1, right? Each item in the array. So increment means go up by 1. So whatever numbers we start with, we want to make each of them go up by 1. So here are some examples. So if we start with 9, 8, 7, forgive my awful curly braces, we end with 10, 9, 8. And if we start with 0, 0, we end with 1, 1, 1. Yeah, you guys got this. If we start with like 10, -2, 50, 100, 1,000, then we end with 11, -1, 50, 100, 1. Okay. Oh. So we're good with what this is supposed to do? Yeah. So let's talk through why this code does that. So we have our array, and it has some contents. So we would change that contents if we wanted to run it with a different array, right? We start with I as 0. In this case, the I is the index in the array, right? So we have our index 0, our index 1, our index 2, 3, 4, 5, if we were to keep going, right? We start counting at 0. Okay, so I is our index. So we go while I is less than the length. So this should be kind of familiar if you're using the length of the array to figure out when you're at the end, right? And you remember last time, if we wanted to change it to less than or equal, you had to do length minus 1. You always have to do length minus 1 to get the last element. So we did all this last Monday, I think, right? All right, am I good so far? So we're going until we hit the end of the array. My array, bracket, I, bracket. So for example, when I is 0, what's my array, bracket, I, bracket? 9. Good. And when it's 1, my array, bracket, I, bracket is 4. I should keep going. And when it's 2, 7. You guys are on a roll. I can't break it. And then we do that plus plus. And what does that mean? Increase it by 1. Yeah? So by doing the plus plus, we're like, oh, increase this element by 1. Does anyone see something missing from this loop? Not yet? So let's run through it in order, okay? So we have I is equal to 0. Is I less than my array.length so far? What's my array.length? 3, right? Yeah, my array.
9 is not less than 3.
That's not correct. Because notice that I is what we're comparing rather than my array I.
Oh, I see.
Do you see that? So if it were my array right here, that's exactly the problem we'd be having. So I is 0. I is less than 3. We're good so far, right? And then we do my array 0 plus plus. So we would change this 9 to be 10. Then we come back here and check again. While 0 is less than 3, because I is 0, my array 0 plus plus. So we now go from 10 to 11. Colin.
I needs to not be 0 every time.
Yeah. Do you guys see that now? We never changed I. So this is kind of our classic pattern of we start by setting it to be 0 or something. We compare what it is relative to here. And then we modify it right here. And we're missing the modify it. And often we start at 0. We compare it to like length or something. And then we do plus plus. But it doesn't have to be. It could be like +2 or something. Right? So we're missing that last piece right there. So again, we have this pretty standard format. So introducing a for loop. So a for loop logically does the same thing. Yes.
For like the last one, could you do an example on cloud nine?
What's that?
Could you do an example on cloud nine now?
Yeah. We can do an example in Cloud 9.
Sure.
Do you want to type it up? Jeff will type it up, and then we'll show it in Cloud 9. So that's our while loop. And Jeff, before you do that though, can you show the slides for me? Meaning show slide 8. Okay, so this is a for loop. Let me
I
see
just
if can
invited
show
you.
Jeff as well.
So when we switch to Cloud 9, you can put it up.
So how do you make it do both at once? Okay, got it. Okay, so this was our while loop version, and this is the for loop version of the exact same code. So take a minute to just stare at it and compare the two. You guys see the parallels? So a for loop is logically the same as a while loop. The only difference is the order that you write things in. So the while loop, you have your initializing at the top, you have your comparison right here, and you have your modification right here, right? And these things could change, like I could be 2, or we could do I plus equals 2, or we could compare it to 5 instead, right? Any of these things could change. And if you were to change it here, you would also change it here. So the only difference between a for loop and a while loop is actually the order in which you write your code. And for loops, I think, are actually a lot easier to read because you read the whole loop logic all at once. So imagine if our loop contents, which is the myArray I++, were like 20 lines long, right? Now your code is getting kind of confusing because this I++ is going to get lost like way down there. You might forget to include it, like I just forgot to include it. So for loops make it easier to keep track of where all your stuff is because they put it all inside of these parentheses. So you're not allowed to write a while loop with this syntax where you write it all in the parentheses, but you are allowed to write a for loop that way. Is this making sense? So yes.
So what is the order in a for loop?
So the order in a for loop is always your initial condition, the thing that it checks, and then modify something.
Can you have multiple of them?
No, you cannot. Now, if you wanted to have multiple of these, you could just stick it on top in front of the code, just like you would do in a while loop. So for example, if you had an I and a J, you could have int I equals 0 be in the for loop and int j equals 0 be above the for loop. It's logically equivalent. If you wanted to have 2 things that it checks, you could use the double ampersand to do a more elaborate check, right? So you could do I is less than myArray.length and j is less than 5, or something like that. And then if you wanted to do this multiple times, you could also add the code down here at the end of the for loop.
Okay, so only the check you can do multiple ones of.
All of them you can, well, yeah, only the check you can do multiple in here. Yeah. So a for loop, you can add on to it just like you would add on to a while loop. Yes.
So why are you doing the I++ before you add it to or like a 1 to the array?
Yeah, so this is one of those scenarios where the order in which the code executes is not the order in which you read it. Just like how functions were our first experience where you would write code in a place but not execute it all in order anymore. So this is another instance of that, where even though you write it all up top, it still goes in this order. So it will still do int I equals 0 at the very beginning. It'll still do the middle check every time you get around the loop. And it'll still do the I++ at the very end. So it is magically figuring out that that's the order that you want it to be in, even though that's not the order you wrote it in. So if you guys find either of these two formats confusing, you can always do the other one, right? Like if you find for loops to be confusing, you can always write it this way with a while loop, and that's fine. The only thing is you should be able to read and understand a for loop, because someone else might write one, or there might be one on the test that you have to read, right? But they're logically the same thing, so you don't need one or the other. Are we good with this so far? The reason I like for loops is I think it makes it a lot easier to read the logic of this, because now the content of my loop contains less stuff. It's just a single line. And at the very top, you kind of get used to seeing this format, like, okay, I starts at 0, I less than length, I plus plus, and you can immediately conclude, oh, this just means do this, where I goes from 0 to 3, or up to 3, but not including, because it's just less than, right? So I think it makes it a little bit easier to read it.
Interlude, Cloud9.
Oh, sure. You have that.
Yep. Hold on one second.
He's jumping around up front, it's warning me.
Okay, so this code's a little bit more complicated than what we normally do in class. I'm not going to ask you guys to replicate it. I just tried to write some stuff to show what's going on. So this is the first version. Julie, if you want to skip back a couple slides. Yeah, that version. Actually, the one before it.
This one?
No, keep going. There you go.
This
It's
one.
that version. So
You
what
guys
I've
see how
got here,
there's no I plus plus?
I've got this stuff that was on the slides. I've got this stuff where we increment my array of I, and then I've got a bunch of other stuff around it that's going to print out what's happening. And then I cheated, and I added some stuff that's going to pause between printing it out, so I don't just run at hyper speed forever. So, like Julie said, we can see what this does. Well, we could see what this does.
Explosion.
Just ignore that, you guys. You don't need to understand what just happened. This is Julia. Is that a programming language?
Yes. All right, well, Cloud9's not running.
Okay, so maybe we'll revisit this once Cloud9 comes back to life. Huzzah! Yay!
All right, so the first time through, it increments 9 to 10. And then what we should do, based on what's on the slides, is we should go on and increment 8 to 9. But we don't. We just keep making that first element in the array bigger.
Do you guys see what's happening?
We never actually move on. So we got to kill this. It's going to go forever. All right, let's try something different. At the very end of the loop, like we saw on the next slide, that's your cue. We're going to make I bigger. Okay, so let's try this again. Let's see if we can finish this time. So we increment 9 to 10. That was the first one. All right, now we increment 8 to 9. Now we increment 7 to 8, and if I hit enter again, we should finish. That was the last thing in the array. And there we go.
Yay.
Okay,
Does everyone understand the code so far? Awesome.
so next thing I want to do is let's do the same thing with for loop. Okay, so what's different with a for loop? We don't do that, we don't do that, we don't do this. Those were the three parts that the for loop took care of for us. So, everyone with me so far? This part, the int I equals 0, I'm going to copy that, and I'm going to put that in the first part of the for loop. That was what we do before the loop starts. Next thing we do is what happens in between each run of the loop. How do we check if it's over? I copy and paste the condition from the while loop. And then the very last thing, Julie, you want to go on to the next slide? Okay, the very last thing is what do we do at the very end of the loop to go on to the next one? So I'm going to copy that in. Okay, so this should do the exact same thing if I didn't mess up.
Whoa.
Where'd my screen go?
It's amazing the number of technical difficulties we have, like at Google, running these things.
You'd think I could figure out how it works. Okay, this should do the same thing, assuming nothing went wrong. There we go, there we go, awesome. Okay, so that was while loop to for loop. While I'm here, any other examples you guys want to do? Should we move on?
Move on. Do you have any questions about what we have so far? Make it, oh, like decrease them each by one? Yeah, let's do that. Can you show it on the code, Jeff?
Yeah.
So what if we wanted to decrease them all by one rather than increasing them all by one? Does anyone have a suggestion? Where?
Which line
Which
do I want
line?
to change?
Wait, so you're talking about like in
We want to decrease it so that 987 would go to 876. Right, so that each of them have gone down by one. How would you do that? What's that? Which one? Which line? Nope. So line 12 is what determines which index we're on. Okay. So this is an important distinction, is that I goes from 0 to 3. So I is representing 0, 1, 2. And if we were to do I minus minus, we would go 0, -1, -2, -3, right? Okay, so want to try again? Where should we change the code so that they all decrease? Yeah. 15. Right? So 15, this is where we actually modify the contents of the array. This is the spot where we actually grab my array I. So we grab my array 0, or my array 1, or my array 2. Right? Are we all good with this? So that's where you would need to change it because we want to change it differently. So we want to decrease it instead. So we would do minus minus.
This is just extra at this point.
Yeah, that too. So it's gonna. So what if instead we wanted to decrease each of them by 5, so that 987 would turn to 432? How would you do that? Where? On line 15. Yeah, so how would you, like that? You almost have it right. So the notation is a little bit different because minus minus means just -1.
minus equals.
Yes, minus equals. That's just a little Java notation thing, but you have the right idea. Yep, so that would decrease each of them by 5. So we'd go from 987 to 6, 5, no, 9 minus 5, 432. Okay, so are we all good with this piece of code? Ready to move on? Okay, let's write a new piece of code. Oh, another example problem. Oh, so this is the squares from the beginning. So Jeff, can you show
Yeah,
slide?
yeah.
Okay. So at the very beginning of the class, I introduced us with printing the squares from 0 to 10, and Alex named the squares for us. We all remember this happening, hopefully. So now here's your example of how you would change that problem into a for loop. It looks really, really similar, right? So we grab our int I equals 0, our I is less than 10, and our I plus plus, and we throw them all into the parentheses. Are we good with this example? This one's pretty basic, so hopefully feel good about that. Okay, so I should have made you guys do that one, right? It's easy to see it happen. Okay, so let's have you do one. So we're gonna print the sum of numbers from 0 to n, where n is the program arg. So n is just a variable. So we wanna print the sum of numbers from 0 to, let's say, 10, or 0 to 15. Do we understand what we're trying to do? So if n is 4, what do we want to print? We want to print the sum of the numbers from 0 to n. So what's the sum of the numbers from 0 to 4? I heard it from somewhere. 10. Right? I'm going to write my examples up here again. All right, what's this one? I heard it. 3. Say it loud around. 4. Right, what if n is 6? Because we take the sum to 4, and then we add 5, and we add 6. All right. So you guys understand what we're doing now, right? We're summing the numbers from 0 to n. Okay, so let's write the code.
I guess you won't do that.
I was gonna do it. Unless, yeah, I'll take it.
Somewhere.
All right. So I have my workspace open, and I'm copy pasting hello world in. Hopefully you all know how to do this by now. And I'm doing sum.java. Rename this to be sum. I'll share it with you at the end so you can just So we're gonna see this on my screen. We're good so far? Okay, so now we have this n, int n, right? And that was just the program argument. So we do integer.parseInt. Is this super familiar to everyone? Does anyone have questions about this line? Was that a question or just no? Okay.
Int. ParseInt.
Oh. Thanks, Dan. Boop. Okay. Cool. So that's gonna, we can sanity check system.out.println. And so now we're printing out n. So what is going to print right now? Whoop.
Yes.
My code did not save. There we go. Good. Okay, so now we're gonna write code to sum from 0 to n, right? So first thing we need, well, does someone want to suggest to me what's the first thing we need? We're summing from 0 to n. when we want to do something from 0 to something, for example, like before when we did the squares from 0 to 10, how did we do that? I heard a whisper back there.
Array.
An array. Okay. So we can't quite do an array this time because what would our array have in it? Any other ideas?
Bless you.
Maybe something related to like the content of this class. How do you do something over and over again, you guys?
Loops.
A loop. And we're going to write it with a for loop because that's what we're learning. Okay? Do you want to write it with a while loop first? Are you more comfortable with those? Or do you want to write it with a for loop? For first? A while first? Okay, we'll vote. Who wants to do while loop first? 1, 2, 3. Who wants to do for loop first? The fours have it. All right. We'll do a while after the fact. Okay, so we're going to write a for loop. So I'm going to get set up here. Okay. So let's have our variable be named I, because that's what we like to do. We can name it anything, right? We could name it num, for example. Okay, so where does num start? We're summing from 0 to n.
0.
0. What's our condition that we want to check? Less than or equal to n, because we want to go up until and including n, right? Less than or equal to n. Then what? What's the last part of our for loop? Do you remember? Plus plus. Notice that I just changed our variable name from I to num, right? So try and mix up the names so that you don't get too into habits. Because if you use I every single time, you'll forget if you're not using I. Like I heard lots of you guys saying I. Okay, so now what we want to do is we want to keep a running total, right? So we want to have our sum. So for example, let's just start with this. Let's just print out num. So what's this going to print?
0.
0. Is that all it's going to print? So we just wrote a for loop that loops where num goes from 0 to n. And what's n? 20. So we're going to print now 0 to 20. Any questions about why it does that? So what if I wanted to print double the number from 0 to 20? Right? It's still looping from 0 to 20. So now we're printing 0246. Okay? Are we good with this so far, what this code does? And so if I were to change n to be 5, let's just return this to printing num. Okay, so we're good so far. Now what we want to do is we want to get the sum, right? So I think we've done something with a sum before in this class, maybe? I think it was on lab 4, maybe, in one of the practice problems. Maybe not. I can't remember at this point. So any thoughts on how to keep track of the sum? So here's what I'm thinking. We want to know what our sum so far is as we go throughout the loop, right? Kind of like, you guys remember min? The problem where you're trying to find the smallest one? We definitely did min, right? And we had min so far so that you could keep track of the smallest number you found so far. We're going to do that where we're going to keep track of the sum that we have so far. So for example, we're going to loop, and after the first loop, we'll be at 0. And then we're going to loop and we're going to add 1 to it, so we'll be at 1. And then we'll loop again, and we'll add 2 to it, so we'll be at 3. So let me walk you through that on the board. So this is going to be sum so far. So when we get to this point in the loop, we're going to be at 0. When we get to this point in the loop, we're going to be at 1. When we get to this point in the loop, we're going to get to 3. When we get to this one, we're going to be at 6. You guys see what I just did? I'm seeing really wide eyes. Is that your vision is bad?
Yeah,
Okay.
that's all.
I thought it was maybe like, oh my god, adding numbers. Okay. Are there any questions about what these numbers are representing? So similar with this one, where are we at this point? 0. Where are we at this point?
1.
Thank you. Where are we at this point?
2. Wait,
2,
what
3.
does that say?
What is it?
Plus 2?
3.
So another way of writing this, if this way I'm writing it confuses you, is it would be 0, and then we would do, I don't want to write this, plus 1 is 1. And then we would bring it down here. We go 1 plus 2 is 3. And then we bring it down here. We would do 3 plus 3 is 6. And then we would bring it down here. And these are 1, 2, 3, 4, 5 in this column. So that's a different way of writing the same thing I'm doing here. If that makes more sense to you. Okay? All right. So we're going to create a variable called sum so far that keeps track of where we're at so far, so that when we finish, we're at the end. So I'm defining my variable int sum so far. And what should it start as?
0.
Its initial value is 0. And then inside our loop, what should we do with sum so far? Plus 1. Like that? What do you guys think? So what's sum so far going to be if n is 4? Like the example over there. Okay, let's walk through it. So when we start, n, I said, is 4. So we're going to do sum so far is 0. And then int num equals 0 is how it starts. Num less than or equal to 4, we're good, so let's get started. Sum so far plus plus. So now sum so far goes to 1. Are you guys following how this code works? So then the next time it loops, what's sum so far going to go to? 2. And then the next time it loops, what's it going to go to? Would it be helpful if I wrote out each iteration of the loop? So what I'm writing out here, if you guys can't understand what a piece of code does, this is going to be your trick for figuring it out. Like on the AP test, if you're given a big chunk of code, it's gonna have questions that like give you a big chunk of code and then ask what is the output of this code. Just like I do in class, right? So how do you go about doing it? This is how you do it. So we're gonna write int n equals, but we're gonna replace the code with what it actually is. So like right now, n is equal to 4 because that's our program arg, right? So I'm replacing the code with the actual values. So then we have sum so far. I'm even gonna take the int out. I'm just gonna write what each of them is. Sum so far. Sorry. And it's starting out at 0. And then we have num is 0. And now we enter the loop. So now, let's enter the first time that it loops. So we check num is less than or equal to 4. Check, because this is 0 is less than or equal to 4. So then we do sum so far plus plus. So sum so far is now equal to 1. And then we do num plus plus. So num is now equal to 1. Good so far? All right, let's loop again. 1 less than or equal to 4. Check. What's sum so far changed to? I'm on line 11. What does sum so far change to? 2. And then num plus plus. So num becomes what? 2. Is everyone with me so far? Okay. Then we loop again. And I can't squat this low, so we're going to loop up to here. All right, so now we do num less than or equal to 4. So really this is num less than or equal to n, right? But I'm filling in the values. So num is 2 less than or equal to 4. And so far, check. What's sum so far become? I hear louder. 3, thank you. And num becomes what? 3. Loop again. 3 less than or equal to 4. Are we getting the hang of this at this point? Check. Sum so far. 4. Num. 4. Go again. 4 less than or equal to 4. Five. Whoa. What did I do wrong, you guys? Are you awake? 5 less than or equal to 4. We're done. Okay. So that's what that code did. And now we're really glad we have computers to do it for us, because that took forever. You want to see how quick it runs this? So I'm going to print out so that you can see it just like I was doing it on the board. Okay. So the computer did that like instantly, right? What we just wrote on the board over forever. Okay. So what's wrong with this code? It doesn't add them up. It's just going up by 1 every time. Okay, so how do we change it so that adds them up? We snap.
Sorry, I can't.
Oh, you can't snap? Well, I have a friend who couldn't snap until he was like 22. Like
He couldn't?
Yeah, he couldn't snap. Like he spent his whole life trying to snap. And he was one of my high school friends, and then he went to college, and he came back from college like 3 years later and was like, hey, I learned how to snap. So
That's gonna be me.
Yeah. It's okay.
I can only
You
snap
can
one.
still do it.
See, I can't even.
Okay, so that derailed us a little. How do we make sum so far add up the numbers?
Sorry.
Does anyone have an idea?
Say that again.
So how do we modify this so that it actually creates the sum? What do we need to change? So we want our sum so far to be, so this is n, right? And this is sum so far. So we want n to go 0, 1, 2, 3, 4, and we want sum so far to go 0, 1, 3, 6, 10. Right? Because each time we added 0, we added 1, we added 2, we added 3, we added 4. And that's how we got to 0 plus 1 is 1, plus 2 is 3, plus 3 is 6, plus 4 is 10. Everyone understands what I'm doing by hand, right? Okay. So the problem with our code is we went 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Instead of having, we want 0, 0, 1, 1, 2, 3, 3, 6, 4, 10. 5, 10. Just ignore that detail. It'll fix itself. So how do we change this so that sum so far gets modified in the correct way? Yes.
Can you just plus n? But yeah, plus equals.
N, like that. Is this right, you guys?
I don't know. Oh, my goodness.
So what's N?
I don't know.
N is 4, right? So this code right here, it added 4 each time. So it went 0, 4, 8, 12, 16. Does everyone see why this code does what it does?
Oh, is it num? Num is the one.
Jeff?
Lines 8 and 9 have new line 10. Now you get the new sum so far.
Thank you. There we go. 4, 8, 12, 16, 20. Okay. No, I shouldn't do that. This is good. Right, so it added 4 each time. What do we want to add each time?
Yes. Oh, 1, 2, 0.
To the result. You want to add the result and point to sum so far. That would be like doing this. Because sum so far is the result. Is that what you want? Maybe. Is this going to be right, you guys? Thumbs? Is it right? Is it wrong? Wrong, maybe, right? No, we don't know. We have no idea if it's right or wrong.
You're tricking us.
Okay, so mentally run through what we did on the board over here, right? I'm not going to write out the whole thing again. But so we have sum so far 0, right? And then the first time we loop, we do sum so far plus equals sum so far. So we do sum so far plus equals 0. So 0 plus 0 is 0. Then we do sum so far plus equals sum so far. So 0 plus 0 is 0. Do you see what I'm saying? So we're going to go 0 and then 0 and then 0 and then 0. Is that what we want? Okay, let's try again. Any ideas? So the first time we go through the loop, what do we want to add to sum so far? 1. Actually, the first time we want to add 0. Right, so actually that's what I'm reading wrong here. So it actually goes, it starts at 0. When we do sum so far is equal to 0. So this is line. Starts at 0. Then we do plus 0 and goes to 0. So the first time we loop through the loop, we want to add 0, and then it becomes 0. And the next time we loop through, we want to add 1, then it becomes 1. The next time we loop through, we want to add 2, and then it becomes 3. The next time it loops through, we want to add 3, and it becomes 6. You guys get it? Okay. So as we're looping through the code, what do we want to write to add to it? So that the first time it adds 0, and then the next time it adds 1, and then the next time it adds 2. The next time it adds 3. Is that a voluntary answer?
You can do sum so far plus or equal the number. Num.
Is this gonna be right? Grace thinks so. Thumbs. Do we like it? Do we not like it? Do we not know? We have a few who like it. Okay, we're feeling good about this one. So then at the very end, we could print out and then we could comment these out if we wanted to, and now you have your working program. Are there any questions about why that was the right answer? Can I see with the thumbs with, do you understand what this code that we just wrote does? Kind of, okay. So we're somewhere between kind of and definitely. Okay. So we'll do some more practice with this, right? But to quickly, let's just quickly replace this right here with our actual code. Where did my marker go? Does anyone see my marker? It's on the
It's like straight up.
Aha, thank you. Okay, so this time n is 4. We start with sum so far at 0 and num at 0 like before, right? We have sum so far now. So we check 0 less than 4, check. I'm not going to modify the num because we didn't change that part of code. We only changed the sum so far part of code. Good. So num is going to loop exactly the same. And that's one of the things I really like about for loops, is that your for loop is all right there. So you know it's going to loop the same every time. You can set your template up like this, and it doesn't matter what's in the for loop, it's going to loop like this. So I think that's really beautiful. So sum so far. So we do sum so far plus equals num. So num, we're not to this line yet. Num is 0. So we do 0 plus equals 0. And we get 0. Then we do sum so far plus equals 1. 0 plus 1. Are there any questions about why it does this? Then we have 1 plus 2. We get 3. We get 3 plus 3. 6. And then 6 plus 4, 10. Okay. So let's move on. Yes, definitely. It's already 8 o'clock. We are not going to get through the whole lecture. That's okay. As long as you guys understand this, because this is super important for you to understand. So if you're feeling good about this, you're doing well. Okay, let's go to the bathroom.
Julie.
I want my teeth to be fresh.
I have an idea. Can I show it to you? I modified the slide slightly.
Do you think I could just crawl under the table?
Instead of
Jesus.
So,
Jesus.
No, right.
Kenny, please. Thank you.
Because we wrote I wrote the wrong
Again?
Yeah.
This is the beginning slide, and then I just kind of kept going with that, because that sort of builds towards this.
I like it. Is this in their copy?
This is in my
This is-
copy. I can move it over.
Yeah. I like it. Can you copy this into the one that they see in our master?
Right now?
Yeah.
Sure.
I like this one, but it looks too similar to like the other one.
So it's pretty much everything. I changed everything up to 16, which is do while, and I added the
I
slide.
should make
After that, it's not color coded anymore because I figure like
Yeah, that's practice.
yeah.
Okay, I like it. Thanks.
Okay, I'll move it over.
I did.
Hi. Questions?
Yeah, so
Why is there no flash?
that's not my question.
That was mine.
When you said that we're not gonna be finishing this, I'm assuming we're not getting to scopes.
I think we're gonna try to go through scope, and we're probably not gonna get very much of it. These slides are pretty thorough, though.
Oh, that's
We
cool.
weren't gonna talk through all of it anyway. If you have questions about this, you should ask. It's important for actually like making your code work. But honestly, it's more of like a reference than some, closely held concept that's important for everything.
I'm sorry if you're looking at the slides. I just deleted all of them. Now they're coming back.
I just noticed like flash.
Yeah, now they're back.
So like a scope
Whoops.
would mean that we wouldn't have to have defined something up here. We could have just from here called it in. Wrong. What is with this version?
It means that if you define it here, it exists from this line
Yeah.
until you hit that curly brace.
Oh, that's
If
convenient.
I were to have defined it here, oops, it would exist from here to this curly brace.
So it exists from wherever it is.
It exists from where it's defined
Mhm.
to the enclosing curly brace, which means notice how when we were up here, it skipped this one because we opened one, so we get to close it. But this was the first one that closed that had opened before it was defined.
Oh.
Okay. So it doesn't mean that we can get a.
It doesn't mean you can
define.
define stuff out of order. You can still only do that with functions and special case stuff like
It
this.
is sort of.
It's sort of in order, and actually, you know how we defined constants outside of the function?
Oh.
Those can be out of order. And that's because they're outside of a function like main, and that's a little weird. But we normally put them at the top anyway so we don't confuse anybody, because it's confusing.
Yep.
Okay. But yeah, mostly it's for when stuff gets cleaned up. You can think about it as at the end of every curly brace, Java goes back and cleans up everything between that curly brace that is no longer used.
That's for you.
So in here it goes, oh, okay, well, the parentheses count as inside the curly brace for loops, unfortunately. So it goes, okay, well, num was defined here,
Yeah.
so we're cleaning up num. You cannot print out num on this line. It doesn't exist. Java will give you an error. So
Oh,
if you
no.
try printing out num here, it will fail.
So
It doesn't exist.
even with.
Error. Error.
Right,
No,
because,
it's not error.
well, that one's because I
Oh.
deleted some so far. That's a different error. But, okay, so let's say I clean this up. Save, run, an error. because
Oh
num
my
doesn't
gosh,
exist.
look at you.
4 weeks. I was gonna ask you if you're using everyone to call, but like.
Now,
But I will start
now
looking
there's
like.
declared
Trying to be on the go. I follow so much technique right now. It's ridiculous.
If you want, I can explain it
It's
otherwise
horrible,
I
but
can
everybody comes like
It's on there. I cleared a bit
Kind of sad.
I just color coded red, blue, pink. Red, blue, pink. Where's the pink? Here's the pink. Red, blue, pink. Red, blue, pink. Red, blue, pink. Red, blue, pink. And then that leads kind of to this slide, red, blue, pink, and then red, blue, pink.
All right, you guys, we gotta get going really fast because we're behind right now. So, thank you for your quick focus. All right, so how did I get ahead of the slides?
because Dan blew them up and put them back.
Whoops, sorry.
It's okay. So,
You're not presenting anymore.
I should present. So there's going going to be lots of problems like these on the lab, and you should be sure to do this until you feel comfortable writing your own loops for things. Okay. So this, I think, is the answer for the one we just wrote, except the only difference is I named it next rather than num. But this should look familiar. Yeah? Okay. We're not going to do this example, but go do this example at home before you start the lab. It'll be a really good warm-up for the lab. So this is just count down a rocket launch from T-10 to T-0, and then say blast off at the end. Cool? So you guys understand what it's asking you to do? All right, so go do that at home. Close your eyes for a second while I skip it on the slides. Okay. You can look again. So here's your really quick summary of how for loops work, right? Just like while loops, declare a variable, check a condition, and then modify it at the very end. For loops do it all at once, and then you have your for loop thing in the middle. So for loops are really good, for example, if you want to do something a fixed number of times. So you could do I is 0, I is less than 5, I plus plus, and now you know it's going to go 5 times. So I might not even matter. You just know you want to do a thing 5 times, right? For example, if you were like writing something over and over again, and you just wanted to do it like 10 times, right? Or, whoa.
I didn't do it.
I put 2 of them up. You're on that side.
It's so pretty. Or if you want to do something over a fixed range of numbers. So for example, if you want to do something from 0 to 4, like we were just doing. Or if you want to do a countdown from 10 to 1, right? Over a fixed range of numbers, right? Okay, so that's how for loops work. I only have one slide. Oh, that's the while loops again. Can I take that back from you now? Yep. Okay. So,
Sorry.
not your fault.
If you mute it, it'll keep giving you that drop down. Just
This is a do while loop. So this is our last kind of loop. There's only 4 kinds of loops. So you're done after this one. Do while loops are really, really similar to while loops. So for example, this would be a while loop that keeps going until someone gives you a positive number. Does this code make sense? So we have our input. We get our input from the user, so we say enter a positive number. They give us -5. Well, input is less than 0. Oh, that's less than 0. We loop again. It's really, really similar to a while loop. The only difference is that we put the input less than or equal to 0 down here instead of up here. So functionally, it's doing the same thing, but it's not doing the check until the very end. So the only thing that changes is that no matter what your state is, you always do it at least once because you don't check until the end, right? So with a while loop, if we had this at the beginning and our input started as 5, it would never enter the loop to begin. Does that make sense? So if we checked at the top, there's a possible scenario, yeah.
So the advantage of this is that you can do it at least once.
So the only advantage of this over a while loop is that it will always do it at least once. So for example, with get input from user, you always want to ask for the input first once. And then if it doesn't work, you go again, right? But there's no scenario where you don't ask for input at all. So that's why we did a do while loop, to be sure it does it at least once. That's the only thing that do while loops do, and that's why I only have a single slide on it, because it's really, really rare that you actually need this. You can do pretty much everything with a while loop, and for the most part, you can just ignore that do while loops exist. But you might see someone's code written this way someday, and then you'll know, oh yeah, this is just the one where we check at the end, no big deal. MBD, right? Just move on. Or the other scenario is you might get yourself into a situation where you're like, I'm using this while loop, but it's not running at all, and I just want to do it at least one time. And then you can do your do while. Is that good? Are we good with just kind of superficially getting this because it's really not that special? Okay. Choosing a loop type. So now that we have these 4 different kinds of loops, right? You're going to get these problems on the homework, and you're like, oh yeah, I'm obviously doing something over and over again. Let's use a loop. Which loop? Right? Okay. So here's how you figure out which loop to use, or here are some guidelines. And we already saw examples where more than one loop worked, right? So this isn't like a set in stone, you have to use this loop, but these are some guidelines. For each loop is for doing something over each element of an array, right? So for each loop was the one for element in array, where in is actually a colon. Does everyone remember that loop? Yeah, okay. So if you see an array and the problem is like, do something over this array, you're thinking, it's a for each loop, right? A while loop is do something until some condition is no longer true. So maybe you want to keep doing this until the person has entered a valid input, or you want to keep doing this until your value that you're doing calculations with has reached 0, or something like that. A for loop is doing something over a particular range of numbers, right? For int I is 0, I goes to 5, I plus plus. It's always over a particular range of things, right? You might be summing, you might be just listing them, you might just be doing it 5 times. So for loops are like, I want to do something from 0 to 5 or 10 to 0 or something like that. Are we good with this so far? And then do while loops are the same thing as while loops, but they go at least once. So that's kind of how you can think about all these different scenarios. So now we are going to do a choosing a loop Kahoot.
Ooh, I'm excited.
Okay, so if you don't know how to get to Kahoot,
That's okay, we don't either.
the game pin is 25140.
25156.
All right, how do I say this? Sign up for nickname.
Oh,
Seashell. Sally
Find the
sold. Yeah. Sally sold seashells by
Oh,
the
I see.
seashell.
I said that when I first got my phone. Like, the worst
Food
thing.
direction 101
Keep those
you.
up.
Oh my god.
Okay, up until Kitten Thief, it was obvious who was who. Who's left over?
Oh wait.
Do we have
Wait,
everyone?
no, it's still me. 5.
I don't see swag yet, though.
You don't have to make it.
Oh, thank you.
All right, we're all in. Let's go.
How did you know I was gonna be swag?
Yeah, we have 10 minutes. Are you gonna play?
Am I gonna play?
Yeah, are you swag?
What are we
Yes,
doing?
I am swag.
Can you tell which one I am?
Is this a quiz or a
Yeah,
game?
It's a quiz.
Let's go.
No.
You got a crucial point in this.
Okay, are we all set?
First,
You forgot to make it inside.
Oh. Wait till I
Wait, is that you?
It's quiz time.
all right, you guys ready?
How do I play this?
So it's gonna ask you a question,
It's gonna ask you a question.
and then on the next one there's gonna be
Holy
4
crap.
giant squares.
Okay. So what is the
What?
best type of loop to
Ah.
find the maximum value in an array?
Sorry, that's a lot.
We're giving you a lot of time because you need time to think. So take your time and think.
Take your time. Take your time to think, guys.
You have like 20 seconds.
Well, this is a hard problem. If it were 20 seconds, you wouldn't be able to figure it out.
I don't know.
I don't know either.
I mean, can I play? Can I guess?
Yeah, but not out loud. You have to.
Oh.
You would have had to log in. This thing
Oh,
has to-
no, I'm pretty sure you could. Nah. Wait,
you
wait,
said
right,
you don't want to check. Whoops. There was a order. Did everyone get this?
Oh,
Did
we
you guys
never
get
read.
Oh, there's an array.
May not have read the array portion.
Okay, not Reddit.
Did we get to see what people chose?
Yeah, it's right there.
Oh, that's what people chose. Okay, I get it.
Oh, I was wrong.
So finding the maximum value in an array, right? The reason we said for each is because it's an array. And what's the easiest way to loop over an array?
Tears.
For each, right? While loop works. It
Okay.
would work, right? A for loop would work, but a for each loop is the simplest because it's already going over an array. A while loop or a for loop, you would have to use the indices and you would have to do a whole thing with I, right? Okay, cool, let's move on.
You have to press next. Oh.
Okay,
Go
so
sing
you
it!
Zero points.
How did you get there?
All right, you guys, what's the best type of loop to find the index of the maximum value in an array?
Wait, what did index mean?
Like the
Zero,
I
one,
that goes
two.
between the
Which
square
conditions
brackets.
then?
Oh.
So like if while you guys have it, if the array were like 1 and 2, you'd want this index is 1. This is 0. This is 2. This is 1. So we want the index of the biggest number. So rather than returning 10, we would want 1. So what kind of loop do you want?
You didn't do the first part.
Yeah.
Oh, you just made it. You made a square. Make it a square.
It's an infinite loop difference at Holy Moses.
So I remember when we first got Kahoot, it used to show you like your answer, like the color of your answer.
I'm just
on the
printing at
screen,
Holy
so, like,
Moses
you know what it
forever.
was. But then, like if you're sitting in a classroom
It's going.
and like there are people in front of you and you can see all of their answers, and if they're all red or something, you can.
So it doesn't
Oh, man. Oh, crap. Oh, dear.
Nice job, you guys. You got. So why did you pick 4 rather than 4 each this time?
That time.
I don't know. I thought because it was in a particular range. Yeah, it's in a particular range. That's a good intuition. So,
Why is this full screen?
Colin, you're making that face again. Like, what the heck?
We're still going over an array, so why not?
You're still going, yeah. So that's what I expected you all to ask, right? So the reason it's not a for each, right, is that for each loops don't give you the index, right? For each loops just give you the values. So if you did 4 element in array, it would go 1, 10, 2, but it wouldn't ever give you the index. So you wouldn't know what index you're at. That's actually a practice problem on lab 4, I think. Did anyone do the practice problems on lab 4 and remember?
Couldn't you still keep track of where you are by just adding 1 to a
Yeah.
thing?
You could, but at that point, if you're keeping track of the index, your index could be the thing that you put in your loop, right? So if you're going to do I starts at 0, I plus plus each time in order to keep track of the index, you might as well just have that be your for loop. Again, a for each loop works, a while loop works, right? But a for loop is really the simplest, best one to go. And if you disagree with me, that's fine. Hold your ground. It's cool.
Yeah, we don't really care that much, but it makes us
Yeah.
pick right answers.
The whole point of this exercise is for you guys to get an intuition of like which loop you want to pick, but there actually is no like hardcore right answer on any of these.
You can do this with any of them, and it's really fine. We're just trying to.
Yeah.
Okay, next.
Let's move on. All right, go kitten thief, whoever you are.
Look, I'm spinning.
What's the best type of loop to prompt for
Oh,
user
wait,
input?
wait a second.
Prompt for user input.
Prompt? Does that mean annoying?
Ask for user input. Ask for user input until a number between 1 and 100 is given. That makes sense? So I'm like, give me a number between 1 and 100. User enters 0. Wrong. Give me a number between 1 and 100.
No. You have to deal with it.
Guess.
Okay.
Deal with your future. Oh, hey, Marissa, can you bring t-shirts on Friday? Or do you think you can come to the meeting on Friday?
Taking
Why?
a picture for the
We're taking a picture for the yearbook, and I want t-shirts. Wait, will you be there? Or will you only be able to, like, get the shirts?
I can do that.
Hey, thank you.
Just remind me on Thursday.
Okay.
March.
Right.
Oh, fudge nuggets.
Dang it.
I got my first one right.
Yeah, I got it right. Oh, I got it right. Yes. I was right.
Dang it, I'm behind Cecil.
I think I got my first one right.
Remember, guys, we said do while loops have pretty much like one use ever, and this is their one moment to shine.
And I remember that.
They don't care about
I remember that comment. I was like, wait, they just said that.
All right.
If you guys don't care about doing while loops are the next best thing.
So you guys are actually mostly
I said
correct because I
while.
told you that you can blow off do while loops and use while loops instead. And so if you want to use a while loop instead for this, that's totally cool. But like this is like the one scenario where do while is better. Remember, the difference with a do while is it does it at least once. And you always want to ask the user for something at least once, and then you keep track. But
If
nice
you
effort.
forget one slide in this presentation, this is the one to forget.
All right, let's move on.
Next.
So still kittens.
Oh, good.
So
Kitten
good.
kittens. Thief, you're doing great, whoever you are. Alright, calculate the product of the first 10 integers, meaning the integers from 1 to 10. We want to calculate the product of the integers from 1 to 10.
Oh, look, they're same colors.
Like,
No.
Yes.
No.
I'm just pure genius.
I don't think it was. I might be wrong, but I don't think.
Hey, do you have sound? I like the music.
Oh, yeah, yes, music.
It's Jeff.
Oh, Jeff. Oh, whoa, the hangout noise.
We got some feedback.
Never mind.
Apparently not.
Literally. What? Can I do sound? Nah, I can't do sound. It has to be from
I
like.
can make some music.
Perfect.
Is that what it sounds like?
Sure. Wait, are there only 9 players? 10?
I think there's 10.
There's 11. There's
Oh.
11 players.
I did not know that.
Maybe help it.
What's the best type of flip to calculate the product of the first 10 integers?
Like too fast.
Let's find out.
Can you make it end?
Can I make it?
Yeah.
I don't know. What is skip?
Wait, where's the
No,
last?
maybe
You know,
not.
just
the last
yeah,
two.
just do skip.
Don't do it.
Just
No.
do
Wait.
If you skip, will that go past it?
I think
Remember
we
when
might
finished
pull,
my
we might pull a
Have
question.
something you want to trade for.
Where's the last 2?
I have a boat.
Someone mentioned.
I have his
Just
phone.
read it out.
Would you like his phone?
No.
I think you can have this one. I'll trade you this one.
What's that? What's lifesaver gummy?
Oh no, this is
Will it go to
phone.
the
I
next
think.
question?
No, these lifesaver gummies are those.
We'll show the answer. So I think you
You can
can.
trade those.
There's only one in here.
Okay, we got 13 seconds.
A gummy for a dollar.
I can wait.
Here we go.
They're literally the same. This one has the one.
Nice job, you guys. Cheers. Alright, so for 6 of us got it. Does someone want to explain why you picked 4? What's that? Yeah, because it's going over a range of numbers. So let's do the next one.
Seashell. Dang it,
Alright,
seashell.
speaking along.
Ooh, who's kitten thief?
Is the explanation to that? Why? What is it?
Determine if a number is prime.
No, I'm swag.
How do you tell if a number is prime?
How do you tell if a number is prime?
If it's not divisible by anything other than 1 in
If
itself.
it's not divisible by anything other than 1 in itself.
So you have to divide.
So you'd have to figure out if it's divisible by anything.
What is anything?
Everything.
Everything.
Okay, but is a number divisible by anything bigger than it?
No.
So if I want to figure out if 51 is prime, I just need to make sure that nothing between 1 and 51 divides it. Well, between 2 and 50, right? Because it should just be 1 and 51 and that's it. So we want to make sure nothing between 2 and 50 divides it. Does that make sense? So to figure out if a number is prime, you want to make sure that nothing between 2 and that number divides
Well,
it.
I already had one with this. Is this touchscreen?
Doing it again.
Oh, you might as well just use the touchscreen part. It's like,
Did it.
rude.
For some reason, I don't think this is the right answer.
I don't
I think it might have.
Oh, whoops.
4 it was.
Oh no.
So
Watch me.
that's our number.
Oh no.
That's alright. I love the way you lie.
No, but it's like these and it like says different.
Julie,
Not too
Julie,
much.
what was the one that was 4? Why was it just 4?
Because it was just going over a certain range of numbers.
So what is just a 4 loop then? Just,
Like,
What's a
why
justified?
would you use just
no, like what it.
For loop is the one we did today that has like the start
Just the
condition,
for.
the
Yeah.
Oh,
condition
the-
and the modifier.
The simplified.
Like I is 0, I less than 0. Praise the Lord. Oh my God. Oh my God. Alright, yes. Breathe. Someone who
That
picked,
was like the happiest when you said yes.
someone who picked
Wow.
4, tell us why you picked 4. One of the two of you. Yeah.
Well, I thought about it because you have like a range of numbers, right? And like it'll go through them and then
Yeah, so
Yeah.
so like if our number that we're checking is 51, we want to go through the range of numbers from 2 to 50 and check if any of them divide it evenly. Yeah? So it's a range of numbers problem.
Once again, any of the loops work.
Yep.
Except maybe for each, but nobody picked for each, so we don't care.
Woo! So while loop is actually a pretty good answer. A lot of you guys picked while loop. You could use a while loop, right? Really anywhere you have a for loop, you could use a while loop.
No, you have to wait.
But the reason we picked 4 is because you're going from like 2 to 50 or whatever range of numbers that are less than that number and checking whether any of them divide it. Are we good? Do we get it now that we said it? Or are we still like, what? Yeah? Thumbs, how are we on that one? Are we good with that one? Okay. Is that a yes? Okay.
The way that I explained it didn't make sense. So, like, did it make sense what I
When
was
you
thinking?
explained
Yeah.
Did it make sense when Yesenia explained it?
Question mark. I don't know. Yeah. Okay.
Yes, that made sense.
Okay. I was just.
I got you, Gracie.
Okay, let's go to the
I
next one.
gotcha.
We're almost out of time.
Okay.
We are at the
Direction of 101.
Good timing.
Last question.
You're okay.
Is anyone fat and or big or just tall or what?
Find the first 10
It's gonna
prime
be like
numbers.
midget.
Can someone name the first 10 prime numbers?
1,
3,
3, 5, 7, 28,000.
1 is not
13.
prime.
First of all, 1 is not prime. 2.
Wait.
1 is not prime. 2, 3, 5, 7.
Best number.
Oh,
11, 13,
Best number.
17, 19, right?
Oh,
That's what you're calculating.
23. 23. Is 31 prime?
29.
That is prime. Is 31 prime? Prime. 37. 30. Not 39.
You can already do it without very
40. Additional 40s.
just now we were counting, like,
49.
and then you were like, what about 4 or something? And you were asking, no, but you were asking about 4. And I was like, are you asking about
43. 41 and 42.
I already
Prime.
completed
What's
my
wrong with you,
Or
college?
twin primes.
I already completed.
Buddy.
No, you're right. 47. Yeah, 47.
All right, you guys.
Yeah.
No.
You want.
We have some answers.
Oh.
Find the first 10 prime numbers.
Please, Jesus Christ.
Oh my God. 11 prize.
All right.
Not
So we have lots of people do 4. Why is it not 4? So the reason it's not 4, so if we were to say find all the prime numbers between 0 and 20, then it would be 4 because you're going over a certain range of numbers, 0 to 20. But when we say find the first 10 prime numbers, you don't actually know what range they're in.
The first 10 prime numbers. Some prime
Yeah.
numbers between 1 and 10.
Yeah.
Okay.
Doesn't make sense. So that it's a very key difference. So do you guys understand how if it were the first, all the numbers between 1 and 10, that's a range of numbers. But the first 10 prime numbers, we don't know what range it's going to be over. So that's why you have to use a while loop.
How many times do I have to loop to get to that number? Do I have to go to 20? Do I have to go to 40? Do I have to go to 50?
We don't
Where's the
know
10
how
prime
long it's
number?
going to take to find 10. Cool. All right. You guys do a pretty good job of that.
Nice.
Who is Kitten Thief? You destroyed. Dan, are you Kitten Thief?
Yes.
I got you. All right. You are kicked out of the game. CJ wins.
You were in one. No.
Yeah, it's not fair.
No. One. I feel bad.
Oh, man.
Okay, I'm gonna do it too.
I'm gonna give it.
That's me.
Well, this
Great.
is a dumb Colin. This is the best part of it. I get to know how you feel about it.
We got thumbs down.
You're welcome.
We got
That
thumbs
may or may
down
not
really
have been
fast.
me.
I made it even.
We have that.
What
Okay.
was our first quiz?
Ha, Colin.
I like loops.
Ratings.
Was that good?
Yes.
We will do it now that we know it exists.
I like
Did you have it?
We're done.
Share my score. Yes.
Okay.
What correct?